All right, let's dive in. Today, we're going to demystify C++. My goal here is super simple. I want to break down the absolute core, the building blocks of this powerful language, in a way that makes sense to anyone, even if you have literally never seen a line of code in your life. So let's get right into it. So let me ask you a question. Have you ever wished you could just teach a computer to think? Or, at least get it to follow your instructions perfectly? Every single time? Well, that's exactly what programming's all about. It's just giving a computer a set of instructions. And C++, it's one of the most powerful tools you can use to do just that. Okay, so first things first, what even is C++? The easiest way to think about it is, well, it's a language, just like English or Spanish. But this one is for talking to computers. And with this language, you can build some seriously impressive stuff. We're talking everything from those blockbuster video games to the actual operating systems that run our phones and computers. So C++ has been around for a while. It was actually built by a guy named Bjarne Stroustrup, and he created it as an upgrade to an even older language called C. Super creative naming, right? Now, you'll hear people call it an object-oriented language. That sounds complicated, but all it really means is that it gives you a great way to organize your code into reusable pieces, kind of like Lego bricks. It's how developers build those huge, complex apps without everything turning into a total mess. And just like any language, it has rules. In English, we call it grammar. In C++, we call it syntax. It's the set of rules you have to follow so the computer can understand what you're trying to say. Okay, that's enough theory for now. Let's be real. The best way to learn this stuff is to actually do it. And in the programming world, there's this time-honored tradition. Your very first program, no matter the language, is always the same. You make the computer say, "Hello, world." So let's see how we do that in C++. Think of every C++ program like a simple recipe. Step 1, you include your tools. It's like grabbing your pots and pans. You need a library called IOStream for handling stuff coming in from the keyboard and going out to the screen. Then you start the main function. This is the real heart of your program, where all the action happens. Inside that function, you write your actual instructions, and then at the very end, you just tell it you're done. And believe it or not, this one little line is where the magic happens. That cout, and yeah, you say it like "see out," is your command to the computer. It basically means, hey, display this. And those two little KK symbols, think of them as arrows, pushing the text "Hello World" onto the screen for everyone to see. That whole line we just saw, that's called a statement. It's one single complete instruction for the computer. And notice that little semicolon at the end? That thing is super important. In C++, every single statement has to end with one. It's literally the period at the end of a sentence. If you forget it, the computer gets confused and has no idea what you want it to do. All right, so making the computer talk is pretty cool, right? But for a program to do anything really useful, it needs to have a memory. It has to be able to store information and remember it later. And that's where something called variables comes into play. Honestly, the absolute best way to picture a variable is to think of it as a labeled box. That's it. You give the box a name, like my stuff, and then you put some information inside it. Later on, you can go back and peek inside that box, see what's in there, or even take it out and put something totally new inside. Now, here's the catch. You can't just throw anything into any old box. C++ is a bit picky. It needs to know what kind of stuff you're planning to store. So if you've got a whole number, like 15, you need an int box. That's short for integer. If you want to store text, you need a string box. For numbers with a decimal point, you'll use a double. And for a simple yes or no, or rather a true or false, you use a special little box called a bool. Let's see this in action. It'll make more sense. So here, we create one of those int boxes. We label it my age, and we put the number 35 inside. Then we use our old friend count to print something out. But look what we're doing. We're mixing plain text with our variable. The computer sees my age, goes and looks inside that box, grabs the number 35, and just plops it right into the middle of the sentence. Up until now, our program has been doing a monologue, right? It's just been talking at us. But what if we want to have a real conversation? We need a way for the user, the person running the program, to give information back to the computer. This is what makes software feel alive and interactive. And the way C++ does this is actually pretty clever. If we have cout for see out to send data out to the screen, it only makes sense that we have syn or see in to bring data in from the keyboard. And check this out, the little arrows are flipped too. The double arrow symbols show the data flowing from the keyboard into your variable. Kinda neat, right? Okay, let's put this to work with a simple but really cool example. We can use sin to ask the user for a number and store it in a variable called x. Then we can do it again for a variable y. After that, the program just adds x and y together and uses count to show us the answer. And just like that, we've built a simple calculator. How cool is that? Okay, this next part, this is where programming goes from just being a list of commands to something much, much more powerful. It's not just about doing step 1, then step 2, then step 3. It's about teaching the computer how to make choices, how to decide things, and how to repeat actions over and over again. This is what gives a program a brain. So we've got a few key tools for this. First, there's the if-else statement. It's a simple fork in the road. Is this thing true? Okay, go this way. If not, go that way. Then you've got a switch statement. Think of it like a receptionist at a big office building, quickly directing you to the right floor based on who you're there to see. And finally, there's the while loop. My favorite analogy for this is the snooze button on your alarm clock. It just keeps going off, over and over, while a certain condition is true, like until it's finally 7 a.m. Let's check out a switch statement to see how it works. First, we'll make a variable, an integer called day, and we'll just set its value to 4. Okay, now the switch statement gets that day variable. It looks at the number inside, which is 4, and it starts checking it against a list of possible cases. Is it case 1? Nope. Case 2? Nope. It's looking for a match. And boom, it finds case 4. That's a match. So it runs the code right next to it, which prints Thursday. Now that break keyword is super important. It tells the program, okay, we're done here. Get out of the switch. Without it, it would just keep on going and run the code for the other cases too, which we don't want. It's a really clean and efficient way to handle a bunch of specific options. So that's great. Our program can now make a decision about one piece of data. But what happens when you have a lot of data, like a list of 100 high scores or 1,000 customer names? Are you really going to create 1,000 different variables? No way. That would be a complete nightmare. We need a better system, a way to organize big lists of information. And that better system is called an array. An array is like a filing cabinet. It's one single variable, but it can hold a whole list of different values. The only rule is they all have to be the same type of data. It's absolutely perfect for storing a list of names or a bunch of scores, or, like we're about to see, a list of cars. So here you can see we're creating an array of strings, and we're calling it cars. Then we just load it up with 4 different car brands. All 4 of those strings are now tucked away nice and neat inside that one single cars variable. Okay, so how do you pull just one car out of that list? You use its position number or index inside square brackets. And listen up, because this gets everybody when they're starting out. Computers don't start counting at 1, they start at 0. So if you want the first item in the list, the Volvo, you have to ask for cars 0. The second item, the BMW, is at index 1. Getting your head around that 0-based counting is one of those key moments in learning to code. And that's pretty much it. We went from a simple hello world to storing data in variables, to getting input from a user, making decisions, and even organizing big lists of information into arrays. These are the absolute fundamental building blocks, not just of C++, but of pretty much any programming language. You now know the basics of how to tell a computer what to do, so the only real question left is, what are you going to build first?